Alright, so we're continuing again with this next example. I'm still with my client Miri on the next example of the polynomial functions. Let's continue from there. Alright, go ahead and work this problem out if you can for me, please. For those of you out there, basically the problem states g of 2x plus 1 minus 2g of x. So the problem looks something like this. G of 2x plus 1 minus 2 times g of x. You guys want to work it out at your house or wherever you are, your apartment. Some of you guys might be in cardboard boxes or something. Who knows? But at least you're living somewhere, right? So if g of b equals b squared plus 3. That's the actual problem. So we already know, based on what we have here, we should be able to plug in, right, the variable, or actually, I'm sorry, in this case it would be, we plug this in right here, the 2x plus 1 into the b squared. Then we plug in x where b is and multiply that result times 2. That's how we would go about doing this particular problem. So once Miri kind of works this particular problem out, we'll go ahead and elaborate a little bit.
I have a question.
Yeah, what's up?
Is this right?
Alright, let me see. Alright, so you took the 2x plus 1, right? You plugged it into...
Or do you take the g out completely? Or
Oh, okay. Take the 2x plus 1 and square it. In other words, you plug that whole thing of 2x plus 1 here and stick it, take this and stick it right there.
Okay.
You know what I'm saying? So then you would take this here that you got, take this and put it here where b is. Then you do 2x plus 1 squared, work that out, then plus 3.
Okay.
And then you go back and say minus 2 times, you know, just put an x right there. 2 times x squared plus 3. Makes sense? And then you work that out. And in the meantime, I'll go ahead and work a little bit of this out myself while she's getting that done. Okay. So 2x plus 1 squared plus 3, and then I'm going to do that out. So this comes into 4x squared plus 4x plus 1 plus 3. Then it says minus 2 times g of x. So the x squared plus 3. So, for those of you out there working with me, if you didn't get this particular problem right here, okay, if you didn't get that, it's not a good look. Alright, we need to make sure we get the problem correct. So, our next step is then to distribute the 2 to the x squared. Is that what you got, or are you a little bit further ahead?
I'm officially stuck.
Okay, what's up? Pause break. All right.
So I have a name.
So 4x squared plus. Oh wait. Okay. So for 4x plus 1 plus 3. Okay, you got that. So it's 4x squared plus 4x plus 4. Good. All right. Now you take the. It says minus 2 times g of x, right? So you plug the x in right here now. Oops. Plug the x in to where b is. So in other words, now you have this whole thing right here, right? Minus 2 times the x squared plus 3. All this is really telling us is we want to put x into whatever my function is. Okay. It could be g of I don't know, g of what it is or something like that, okay? And you plug this into whatever it is. All right, and you get x squared plus 3. You don't have to do any major work like this. Just plug in the variable here.
Okay.
And then you simplify. Make sense? We're going to distribute that 2x plus 3. So our next step would be to rewrite this, what I call rewrite step here. Rewrite at 4x squared plus 4x plus 4, or rewrite and simplify. 4x squared plus 4x plus 4 minus the 2x squared minus the 6. Now, at this point, I combine like terms. 4x squared minus 2x squared, and then I combine like terms. 4 and 6. So, Miri, what's 4 minus 2? 2, right? So 2x squared plus 4x, there's nothing else to match it with. And then 4 minus 6 is what?
-2.
-2. And that becomes my answer.
That's it?
Look at that.
Okay.
Is that what you got?
Uh-huh.
Alright, cool. And then, shoot, we're good to go on that, right? Any questions on that so far? As you see here, right, it was 2x squared plus 4x minus 2. And we're good. Okay? Cool. Alright, let's look at the next one. Okay. On these, this is something you got to pay attention to. And this is for everybody out there. My kids in previous past had issues with these, not necessarily huge issues with the graph. What you have to end up doing is memorizing what the flow is of the graph. Okay? End behavior. This section is called end behavior. So end behavior of polynomial graphs. Alright, now the 4 graphs you're going to have are going to be, first of all, you're going to have degree where it's even and the leading coefficient is positive. The degree is even and the leading coefficient is positive. That means the end behavior is going to be like a field goal right here where 2 hands are up. They go up like a parabola going up. So when you draw the Cartesian plane, it looks something like that. Alright? And as you see, as x approaches positive infinity going this way, y values go to positive infinity. Okay? As x goes to negative infinity, y goes to positive infinity. Now I'll put that actually over here. X goes to negative infinity. Y goes to positive infinity. Okay? That's the end behavior. Alright, the domain here is all reals. Alright, the domain is all reals. The range is x is greater than or equal to, I'm sorry, not x, it's range. Y is greater than or equal to 0. Alright? You understand that so far? It's just the graphing portion. Now, if the degree is even, but your leading coefficient is negative, guess what happens? It doesn't go both up, it goes both down. Right? So my degree is also even here. LC is negative. The Cartesian plane looks like this, both sides down. Almost like that song. What's the song? Everybody hands go up and they stay down now, right? So here they go, x goes to positive infinity, and then y also goes to, in this case, it approaches negative infinity. So x goes the positive direction, y goes in the negative direction. As x goes in the negative direction, y goes in the negative direction also. Alright, that's the limit as it approaches that. So the domain, again, is all reals. The range is y is less than or equal to 0. Okay? Any question on that so far? Pretty simple, but you have to memorize all the end behaviors. You can't look at a graph or look at a table or anything like that when it comes to your quizzes and stuff. Now, if the degree is odd, but the leading coefficient is positive this time, alright, it kind of looks similar to, if you can see, my hand's like this, my other hand's like this. I don't know how to really do it, but like this and like that, I guess. So it kind of looks like a cubic function, if you will, where this side, the right hand side, as x approaches positive infinity, y goes up to positive infinity. As x approaches negative infinity, y goes down to negative infinity. So the graph on the Cartesian plane really looks like this. Alright, so as x approaches positive infinity, y goes to positive infinity. As x approaches negative infinity, y goes to negative infinity. Alright, and the domain here obviously is negative infinity to infinity, which is all reals. The range, however, is also all reals. Okay? Don't forget that. Any question on that so far? Pretty simple again, right? Now, your fourth and final one, and I'm going to erase the left-hand side real quick. Actually, no, I'll erase the middle. I'm going to erase that red one. And replace it with another red one. Your next one's going to be degree odd. But the LC is negative this time. Okay? Your graph is now going to look like the opposite direction. Okay? The opposite direction, totally. Alright? As x approaches positive infinity, y goes to negative infinity. As x approaches negative infinity, y approaches positive infinity. Alright, so you see a direct difference here. And the domain, again, is all reals. The range is going to be all reals. Okay? Any questions on that one so far? It's still pretty simple if you really just look at it, right? Alrighty. Cool. So that, my friends, is that particular section of end behavior on the video. And looks like we're pretty much making good time on when it ends. Like that was perfect. So to all y'all out there, make sure y'all learn something from this. If you need to write this stuff down, I suggest you press pause on the video and make it happen. Alright? Holla.